So in the second video looking at simultaneous equations, we'll be working through a series of different examples. Now in the description below, I'll include some notes on the steps and the questions you need to ask to solve simultaneous equations. I'll also include a copy of a blank set of the example questions for you to work as you're watching the video, and also then some practice questions for you to test your understanding along with their answers. Now, while working through the following examples, please refer to the note sheet with the following flow diagram attached in the description below, which goes through the questions you need to ask yourself and the steps and the method needed to solve equations simultaneously. Now, although this diagram or this flow diagram looks a little bit confusing and looks a lot for you to remember, what you need to remember is that simultaneous equations questions are going to be written differently. Now, in an exam, you'll only generally get one of them. You're not going to get a load of them. However, when you're practicing and from a textbook or a homework, you may get a series of simultaneous equations in which you might have to look at things slightly different, and you might need to jump sudden stages in terms of this flow diagram of what we're looking at. Now, in terms of how the flow diagram works, all you need to do is ask yourself, this will be the very first question. So does one of the letters have the same quantity? Are the X's and the Y's the same? And obviously, yes, no, you just answer the questions, and then it should tell you what you need to do to move forward and go about working to the final answer. Now, we'll be referring to each question to this flow diagram. So if there is anything that you're not sure about, then obviously just continue watching and I'll try and explain it as we go through them. So let's have a look at the very first question. So here what we need to do is, now the general process of working with simultaneous equations is having the same quantity of one of the letters. Now it doesn't really matter which letter you've got the same quantity of, as long as one of the letters has got the same number in front of them. Now the key thing to remember with algebra is that if there is no number in front of a letter, then you can just assume it is 1. Now in this particular question, I've got two equations. In the top equation, I've got 1x and I've got 2y's, and in the second equation, I've got 1x and I've got 1y. Now don't worry too much about the numbers. Now for this, I've got the same number of x's. So that's the first box checked. So I'm going, yes, I have. Now the next thing I then need to look at is, what is the sign of those letters, of the one that I've got the same. So as the x is the same, what I've got to do is I've got to look at the sign of both the x's. Now here they're both positive, so they're both the same. So what I then need to do is I then need to subtract both equations. So here, are the lengths the same? Yes. So I need to subtract both the equations. So here I've got x plus 2y equals 5 and x plus y equals 3. So if I take away the two equations, then what I end up with is x take away x, which is nothing, 2y take away 1y is 1y, and 5 take away 3 equals 2. Now if you've done this correctly, you should find that one of your letters should disappear, which in this case my x's disappear, leaving me left with one letter and a value. So from this, what I then need to do is work out what 1y is, so therefore y equals 2. Now knowing that y equals 2, all I've now got to do is pick one of the two equations from the original set of equations. So if I just get rid of this, so think to yourself, which one looks the easiest? Well, I'm going to go for the second one. So then using x plus y equals 3, well, I know that y equals 2, so I've got x plus 2 equals 3, which therefore means that x must equal 1. So my answer is going to be x equals 1 and y equals 2. And there is my final answer. So moving on to the next question. So again, here I'm looking at asking myself, have I got the same number of x's in both equations? No, because this one's got 4 and this one's got 1. Have I got the same number of y's? Yes, I've got 2 y's in both of those two equations. So the next thing I've then got to decide is, are the signs of the y's both the same or are they different? Well, they're both the same, so what I need to do is take away the two equations. So what I've got is I've got 4x plus 2y equals 14, and I've got x plus 2y equals 5. So my x is the same, they're both add, so what I need to do is take away the two equations. So 4x take away 1x is 3x, 2y take away 2y is nothing, and 14 take away 5 is 9. So again, I'm doing well, and I know I've got on the right track because one of my letters at this stage should disappear, which the y's have. So working with 3x equals 9, well, if I divide, get rid of the 3, divide by 3, so x is going to equal 3. So I've got one of my values of one of my letters. So next, what I then need to do is pick one of the equations. So you go for the most simplest looking equation. So then using x plus 2y equals 5. Now knowing that x equals 3, I've got 3 plus 2y equals 5. If I take the 3 over by subtracting, I end up with 2y equals 2. Now I can get rid of the 2 by dividing by 2, so y equals 1. So my final answer for this question is going to be x equals 3 and y equals 1. Now moving on to the next equation. So again, I'm looking at asking myself, have I got the same number of x's? No, because I've got 8x and I've got 3x. Have I got the same number of y's? Yes, because I've got 6y and I've got 6y. So from that, what I've then got to do is decide, well, are the signs of the y's the same or are they different? Now in this case, they are different because I've got minus 6y in the first equation and positive 6y in the second equation. Now when the signs are different, what I need to do is add the two equations together. So here I've got 8x plus 3x, which is 11x. I've got minus 6y plus 6y, which disappears and becomes 0. And then I've got 28 plus 27, which is going to give me 55. Now again, it's looking good because one of the letters should disappear. In this case, my y's have disappeared. So if 11x equals 55, then that means that x is going to equal 5. So once I've done that, what I then need to do is pick one of the equations. And again, doesn't matter which one you go for. So let's go for the top one. So I've got using 8x minus 6y equals 28. And when x equals 5, then what I've got is I've got 8 times 5, which is 40, minus 6y equals 28. So if I take the 40 over to the side by subtracting 40, then what I get is I get minus 6y is going to equal minus 12. So then from this, I've got to get rid of the minus 6. So I do that by dividing by minus 6. So here I've got y equals minus 12 divided by minus 6, which gives me positive 2. So my answer for this question then are going to be my two values which I've worked out, which is x equals 5 and y equals 2. And I'm just going to write it out. Try not to leave your answer as how I've written it. Try and write out the answer so it's a little bit easier, a lot more neater for you to get your answer marked, and obviously for whoever's marking your work to see what the answer is without having to search for the answers in your working out. So let's move on to the next question. So again here, ask yourself, have we got the same number of x's? No. Have we got the same number of y's? Yes, because I've got one y. Are the signs of the y's the same or are they different? Well, they're the same. So what I need to do is take away the two equations. So 4x take away 3x is just 1x. Minus y minus minus y. So what I've got is I've got this, which then becomes a plus, which then becomes 0. So that then disappears, and 4 take away 2 is 2. Now straight away I can see that x equals 2, so there is one of my values. So then using one of the equations, as I said, doesn't really matter which one you've got, so I'm going to use this one. So here I've got, so when x equals 2, then 4 times 2 is 8, so 8 minus y equals 4. So what take away from 8 gives you 4? Well, y must equal 4. And there are my two values. So the answer for this particular question is going to be x equals 2 and y equals 4. Now moving on to our next question again. Here we've got, so we asked ourselves, have we got the same number of x's? Yes. Have we got the same number of y's? Yes. Now in this, because I've got the same number of x's and y's in both, but the signs are different, I can pretty much choose which symbol I want to go for. So you can either choose to add or subtract. So let's just go for making the x's the same. So I'm going to take away. Now again, at this stage, one of your letters should disappear. And if it doesn't disappear, you need to go back and you've probably not done something incorrect. Where you've added, you should have subtracted, or where you subtracted, you should have added. But one of your letters at this stage should disappear. So 3x take away 3x is nothing. Minus 2 minus positive 2. So minus 2 minus positive 2. Well, they become a minus. So I've got minus 2, which equals minus 4. And 12 minus 24 gives me minus 12. And I've just forgot my y. So therefore, if I take the minus 4 over to the side by dividing by minus 4, I'm left with y equals positive 3. So there's one of my answers. So then taking one of the equations, I've got 3x minus 2y equals 12. So when y equals 3, I've got 3x minus 2 times 3, which is 6, equals 12. I take the 6 over by adding 6. So 3x equals 18, and I take the 3 over, and so x equals 18 divided by 3, which is 6. So the final answer for this particular question is going to be x equals 6 and y equals 3. Now moving on to our next example. So here what we've got is we've got x plus 2y equals 4 and 4x plus 5y equals 7. So again, ask myself, have I got the same number of x's? No, because I've got 1 and 4. Have I got the same number of y's? No, because I've got 2 and 5. So this is where we need to do a little bit of manipulation. Now, what I need to do is decide, okay, by multiplying, how can I get either the x's or the y's the same? Now, ask yourself, if I change the x to a 1x, is there a number that I can multiply 1 to get 4? Well, yes. If I times that by 4, and everything by 4, which is the most important thing, I'm going to end up with 4x plus 8y equals 16. Now, if I take the second equation, which is 4x plus 5y equals 7, you can see now that my x's are now the same. So then once my x is the same, I then got to ask myself, are the signs of those x's the same or are they different? Well, they're the same because they're both positive. So I take away the two equations. So 4x take away 4x is nothing because that disappears. 8 take away 5y is 3y. And 16 take away 7 is going to give me 9. So from this I can then work out what y is. So I divide by 3. So y equals 3. And there's my first value. So picking one of the equations, generally go for the easiest one. So I'm going to go for this one here. So using x plus 2y equals 4. So here I've got, and y equals 3. I've got x plus 2 times 3, which is 6, equals 4. So taking the 6 to the other side by doing the opposite, which is taking away 6, we end up with x equals minus 2. Now again, your answers could be positive, could be negative. Again, it all depends on what level the question is written at. So your final answer is going to be these two values. So x equals minus 2 and y equals 3. Now, if you do find that one of your answers is a fraction or a decimal number, I strongly recommend leave it as a fraction. Don't write answers as decimals, always leave them as a fraction. But again, the only time that generally will happen is if it's on a higher GCSE paper or your question is deemed as a high level question. But generally, if you end up with a decimal answer, unless it's 0.5, leave it as a fraction. So then moving on to our next example. So here I'm going to say, right, well, okay, I haven't got the same number of x's, I haven't got the same number of y's. So I think, okay, well, is there a number that I can multiply 3 to get 7? Well, there is, but it's not going to be a nice number. So let's have a look at the y's. Is there a number that I can multiply 4 to make 8? Well, yeah, because if I times that by 2, then I end up with 6x plus 8y equals 14. Now just make sure that when you are multiplying an equation, you don't forget about the number, because a lot of students will forget about that number. So taking the first equation as it is, I've got 7x plus 8y equals 3. So from this you can see that my y's are the same, and also the signs of those are the same as well. So what I'm going to do here is take away the two equations. So here I've got 7x take away 6x, which is just 1x, and 3 take away 14, which is minus 11. So therefore, x equals minus 11. So then picking one of the equations, so using out of the two, which one looks probably easiest? Well, the smallest numbers is probably the easiest. So using 3x plus 4y equals 7. Well, I know that x equals minus 11. So here I'm going to have minus 33 plus 4y equals 7. So what I then need to do is add 33. So then I've got 4y equals 40. And so therefore y equals 10. So my final answer is x equals minus 11 and y equals 10. Now if I picked the second equation, so here I used the bottom equation, but if I used 7x plus 8y equals 3, now again, knowing that x equals minus 11, I'm going to have minus 77 plus 8y equals 3. So I add the 77, so that disappears. So I've got 8y equals 80, take the 8 over, and so y equals 10. And you can see that I still get the same y. So it doesn't really matter which equation you use, but if you've done it correctly, you should end up with the same answer. And again, it's always good practice for you to write down what your answers are at the end of your answer, so it's not like a treasure map like what I've done. So moving on to our next example. So again, ask yourself, have I got the same number of x's? Have I got the same number of y's? No, I haven't. So then ask yourself, okay, well, looking at the smallest number of x, is there a number that I can multiply 3 to get 4? No, not a nice one. Is there a nice number that I can multiply 2 to get 4? Well, yeah, because I can times that by 2. So what I'm going to do is here I'm going to multiply my second equation by 2. So what I then get is 8x minus 4y equals 4. And what I'm going to do is I'm just going to simply write the first equation, which is 3x plus 4y equals 29. So now I can see that my y's are the same, but the signs are different. So here what I do need to do when the signs are different, I need to add the two equations. So 3x plus 8x is 11x, 4 plus minus 4 is nothing, and 29 plus 4 gives me 33. Now working this out, should work out that x equals 3. So then using one of the equations, so let's go for 3x plus 4y equals 29. Well, I know that x equals 3, so this is going to be 9 plus 4y equals 29. I take the 9 over by taking it away, so I end up with 4y equals 29, take away 9, which is 20. I then divide by 4, so y equals 5. So my final answer is going to be x equals 3 and y equals 5. Now moving on to this question. Now this question is, if we look at the values, so looking at the smallest x, is there a number that I can multiply 2 to get 5? Well, no. Is there a number I can multiply 3 to get 4? No. Now, if that's the case, then what we need to do is we need to multiply both the equations by two different numbers. Now, for this, what you need to do is pick one letter. So pick a letter. So I'm going to go for, now it doesn't really matter which letter you go for. Again, I'm just going to go for x. Now, what I then need to do is then, looking at the numbers of x, so I've got 2 and a 5, I need to find the lowest common multiple of those two numbers of 5 and 2, which in this case is going to be 10. So what I want to try and do is multiply both the equations, so I end up with 10x. Now to do that, what I need to do is I need to multiply 5x by 2 to get 10x, and I need to multiply 2x by 5 to get 10x. So if I multiply those two equations by these two separate numbers, then what I end up with is 10x plus 8y equals minus 4, and I'm going to end up with 10x plus 15y equals 45. Now from this, by multiplying the two, as you can see, my x's are now the same. I don't know why I've crossed that out. Need to be highlighting that. So here you can see that my x's are now the same. So the next question I need to ask is, are the signs of my x's the same or are they different? Well, they're the same, so I take away the two equations. So here I've got 10x, take away 10x, which is nothing, which is brilliant because I want one of the letters to disappear. And I've got 8 minus 15, which gives me minus 7y. Then I've got minus 4 minus 45, which leaves me with minus 49. Now, generally speaking, if you're not comfortable with working with negative numbers, try and rewrite the biggest equation on the top. So if you were to flip this, you'd end up with less likely to end up with negative numbers. But if you're quite comfortable with negative numbers, then it's going to save you a bit of time. So going back to the question, I've got minus 7y equals minus 49. So I need to divide both numbers by minus 7. So then that disappears. So I get y equals minus 49 minus 7, which leaves me with positive 7. So then picking one of the equations, so again I'm going to go for the bottom one. So using 2x plus 3y equals 9, and knowing that y equals 7, I get 2x plus 21 equals 9. I then take away the 21, so I've got 2x is going to equal minus 12. And so therefore take the 2 over, divided by 2, so x equals minus 6. So my final answer for this particular question is going to be x equals minus 6 and y equals 7. Would I lose marks if I wrote the y first? No, not particularly. It's just right in alphabetical order, and that is absolutely fine. So then moving on to our last example. So again, thinking to ourselves, I've got my x's are different, my y's are different. So is there a number I can multiply 2 to make 3? No. Is there a number I can multiply 4 to make 5? No. Well, not a nice number anyway. So what I need to do here is pick one of the letters. So try and go for the smallest letters rather than the bigger letters. So here I'm going to go for my x's to make the same. So I've got to think to myself, what's a common multiple between 2 and 3? Now, don't worry about it being minus 2. Just treat the digits as it is on the face value. So what's the lowest common multiple? So what number appears in the smallest number appears in the 2 times table and the 3 times table? Well, that's going to be 6. So to make 2x into 6, I need to multiply it by 3. And to turn 3x into 6x, I need to multiply that by 2. So multiplying out those two equations, I end up with minus 6x, 3 times 4 is 12y, and 3 times 13 is 39. And then 3x times 2 is 6x, minus 5 times 2, which is 10y, and I've got minus 8 times 2, which is minus 16. So now my x's are the same, but the signs are different because one's a minus, one's a plus. So when the signs are different, I need to add the two equations. So minus 6 plus 6 is 0. 12 plus minus 10 is just 2y. And 39 plus 16 is going to give me 323. Now from this, what I then need to do is divide the two numbers. So here I'm going to divide by 2. So here from this, what I've got then is I've got y equals, and it's going to be 11.5 is my final answer for y. So from this, what I can then do is so I can leave it as 11.5 or I can write 11.5, but I certainly would not round up. So do not round up. And again, if it was more of a nasty decimal number like 2/3, again, just use fractions if need be. So then using the simplest out of the two equations, so I'm going to go for the bottom one. So using 3x minus 5y equals minus 8. Well, I know y equals 11.5, so I've got 3x minus 5 times 11.5 equals minus 8. Now 11.5 times 5 is 57.5, so I've got 3x minus 57.5 equals minus 8. So I take the 57.5 over to the side by adding it, so that disappears. So I've got 3x equals minus 8 plus 57.5, which gives me 49.5. And then I divide by 3, and so I get a final answer of 16.5. So x equals 16.5. 11.5. And like I said, having decimals is, again, perfectly valid. You could easily get, particularly if it involves money, and so that would first y would be £11.50 and x would be £16.50. But again, just write down your final answer, and if the decimals are not nice, worse than that, so let's say like a recurring decimal, then leave your answer as a fraction. So x equals 16.5 and y equals 11.5. Now moving to the extension questions. Now this is where you might have to do some rearranging. Now, generally speaking, what you want to try and do is make sure that the format of your first equation is exactly the same as the format in your second equation. So with question 1, now I won't answer all these questions, but we'll try and get it in a position where it's very similar to the examples that we have done. So here I've got 2x equals 5y plus 4, and here I've got x equals 4y plus 5. Now one thing you might want to do is to have numbers on one side, letters on the other. So what I need to do is take the 5y over to this side and the 4y over to that side. So how that works would be to subtract, and everything then becomes very, very similar to what it was before. So I could rewrite question 1 like so. Moving on to question 2. Again, I've got 3x equals minus 2y plus 2, and I've got 2x equals minus 6y plus 13. Now it is possible for you to do exactly what we've done, because x is the subject for both equations. They're both, I've got x on one side and y's and numbers on the other. So again, they're both the same format, so I could just go about my business and do exactly what it says on the flowchart. However, if you feel more comfortable having letters on one side, then all I need to do is take the y's over to the side, so that becomes plus y and that becomes plus 6y. So how these equations would be rewritten as 3x plus 2y equals 2 and 2x plus 6y equals 13. And then I obviously need to go about doing the same as what I did before. Moving on to question 3. Now here we've got 6x plus 2y equals 14, and I've got 3x equals 5y plus 10. Now in the first equation I've got x and y on the same side, so what I need to do for the second one is do the same. So I need to take the 5y over to the side, so what I'm going to end up with is 3x minus 5y equals 10. And then what I would then do is I'd use this as one equation and this as another. With question 4, what we've got is we've got 2x equals minus 4y plus 15, and on the bottom I've got x plus 5y minus 21 equals 0. So again, try and get letters on one side. So for this one I need to add 4y, and for this one I need to take the 21 over to this side to add 21. So how this there will then write is 2x plus 4y equals 15 and x plus 5y equals 21. And there you go. Now for question 5, so let's just get rid of this so we've got a bit more space. So with question 5, I've got x minus 2y minus 4 equals 0, and I've got 3x minus y plus 3 equals 0. Now again, with this I don't have to move anything around because I've got everything all on one side, and that is absolutely fine, and they're both equal to 0. However, if you feel more comfortable of having letters on one side, then all I need to do is take, on the first equation I need to add 4, and on the second equation I just need to take away the 3. So what I end up with is x minus 2y equals 4 and 3x minus y equals minus 3, and these then are my two equations. And then finally for question 6, so again let me just get a bit more extra space. So with question 6, I've got 3x minus 4y equals 4.5, and I've got 2x minus 10 equals minus 2y. So the first equation is absolutely fine. I've got letters on one side, numbers on the other. But for this one, what I need to do is I need to take the 10 over by adding 10, and I need to take the y over to this side by adding 2y. So then what that second equation will therefore look like is 2x plus 2y equals 10. And therefore it would be this equation that I use and this equation that I use, and then use the flowchart to then work out what the two values are going to be. So I will put some practice questions with the answers in the description below for you to practice simultaneous equations. It is going to take a bit of practice. There are different circumstances, so I strongly recommend that you do use that flow diagram to give you a bit of a prompt as to what you need to do. But these questions that you can see where you've got a bit of rearranging to do are generally on the higher GCSE paper. And like I said, once you've mastered it, you can then start asking yourself other questions of, right, okay, this doesn't quite look right, so what do I need to do to make it look like the format that I'm more used to? And then you just go about doing that.